Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Okay, so this is the third video from week number 10. Still under chapter of differential equation, but we focus on solving the constant, or we call as the particular solution. Okay, um, when we talk about the general solution for an differential equation, kalau in the previous video, once you settle for the finding the general solution from differential equation, okay, your equation consists a constant, right? Let's say for example your differential equation, okay, therefore you akan dapat di sini lah y equal to x squared over 2 plus c, is it? Right. So by using this particular solution, or by using a method of substituting a value of x and y, therefore you may solve the c, and therefore kita akan dapat a specific equation that can that when we differentiate we will have this dy over dx. Okay, right. Okay, so we start with an example. Okay, solve the differential equation dy over dx equal to x, given that y equal to 3 when x equal to 2. Usually these two values of x and y given. Okay, otherwise we cannot even solve our c, the constant of integration. Alright, so what we're gonna do is, first thing first, of course you have to use the separable method. Kat sini you have to use the separable method, which is put x at one side, y at one side, or for this example you boleh integrate straight away. Okay, and later substitute the x equal to 2 and x equal to 3 into this one lah. Therefore you akan dapat c equal to 1. Therefore the particular solution for the differential equation is y equal to half x squared plus 1. Okay, tak sure macam mana nak how to confirm this is the answer that we need. Actually you boleh try to differentiate whether you dapat tak semula this dy over dx equal to x. Okay, boleh check. Okay, so let's focus to the next example, another level of the question, which is write the equation of the curve satisfying the x dy over dx equal to x, given that the point 1, 4 lies on the curve. Alright, so remember in the previous video we have two methods in order to solve, especially when we have a reciprocal function like this. Ini kita panggil sebagai reciprocal function, meaning the highest power of your function over there is 1, power the 1. Okay, even though your function is only x or your function is only y, but this y and x is power 1, so kita identify this sebagai reciprocal because there is no integration of logarithm, tak ada, unless you boleh gunakan integration by part in the week of technique of integration. Tapi we have a reciprocal function like this. So remember kita ada dua method, either you nak use the k, constant k, or you boleh letak plus c1 and plus c2, both left hand side and right hand side. Okay, so from my slide I provide only a method of plus c, because I put plus c1 and plus c2 right after you integrate. Okay, so you can see from here, integrate 1 over y, you will have ln y plus c1. Integrate 1 over x, you dapat ln x plus c2. Okay, and then simplify, you will have ln y equal to ln x plus c, where c equal to c2 minus c1. Okay, which is you boleh move the c1 to the right hand side, and then you just substitute with c. Okay, later, next. Our objective to solve the constant, right? Because kita nak substitute the value given, right? The information given, right? So what we need to do is you have to change this ln become an exponent, meaning you put your base, or sorry, your number become the subject, And then your base kat sini, ln is equivalent to log exponent y, remember? Okay, so move your base become base to your index. Base of log akan jadi base of index. Therefore, you dapat exponent ln modulus of x plus c. Okay, bila ada modulus plus c, bila you ada index with power yang tambah, so actually dia datang daripada multiplication process. Exponent, base yang sama, you multiply, what happen to the power? Power akan tambah. Alright, so after that, it's become y equal to x. Kenapa suddenly boleh dapat x from here? X ni dia datang daripada exponent log base exponent x. So remember, bila cancel out exponent, if your base of your index is equivalent to base of your log, you will cancel out the whole thing, and then the remaining is only the number. Since our number is x, so therefore tinggal x sahajalah. Multiply with c. Mana hilang exponent power of c ni? It's actually from where your c is equal to exponent power c, because any number power constant still a constant. After that, kita dah tahu this is our final answer, and then baru you substitute x equal to 1, y equal to 4. Later dapat c equal to 4, therefore this is your final answer. Okay, how about I nak gunakan the second method, which is gunakan k. Right? This is I make a comparison. Ini kita panggil sebagai gunakan k constant. Over here I put is C1, C2 yet that we have done in the previous slide. Okay, so let's focus untuk yang plus k ni dulu. Alright, so as similar, which is separate both variable according to the variables yang you nak lah. Okay, for example, y variable at the left hand side, x variable in the right hand side. Okay, so over here you can see I have 1 over y dy, 1 over x dx. Okay, now I'm using the k, which is I put only a constant just beside the x, only at the right hand side. Dia tak sama macam plus c. Tengok plus c, both side, right hand side ada plus c1, left hand side there is a plus c2. Okay, kalau you nak gunakan k, ini boleh refer page 402, that explain more detail. Okay, so if you put plus, if you want to use the k constant ni, only one side, either nak letakkan on the left hand side or the right hand side, but usually you put in the right hand side. Okay, after that ln and ln boleh cancel out, so the remaining is only the number inside the logarithm lah. So actually straight away dapat sama. How many steps you skip? 1, 2, 3, 3 step. Okay, ini kalau in case kalau you ada both log lah, choose one side. Tapi case let's say and this one is not a log, not a reciprocal, but one side is only a reciprocal, then boleh gunakan the same method. Put only a constant, multiply with the function to the right hand side only. After that substitute as usual. Okay, right, so let's take a look at this exercise 23.06, page number 406. Okay, tapi you buat only question number 1 and 2, because number 3, this is the second ODE. Second ODE is not in our syllabus. Question number 4, memang I dah already mention, no need to complete the question number 4. Okay, so focus 1 and 2. Alright, so let's take a look at the question number 1. Write the particular solution of this differential equation. Right? So dy over dx equal to 6x, which satisfy the condition y equal to 5 when x equal to 1. So first thing first, of course, you have to use the separable method. Therefore, I have 6x dx. Integrate both sides. Integrate 1, we have y plus c1. Integrate 6x becomes 6x squared over 2 plus c2. Any for this case, it's not suitable to use the k constant because this one is not a reciprocal. K constant just now is only applicable for logarithm or reciprocal function. Okay, now put a constant at one side because our objective untuk dapatkan similar to this final answer in delta. Y equal to 3x squared plus C, where C equal to C2 minus C1. Okay, this one is only a constant. You boleh let any number kan. Kalau you tak suka dengan C, maybe you boleh let with A and B. Later you dapat H, for example. It's only a constant. Alright. Kenapa C equal to C2 minus C1? Kenapa tak letak C1 minus C2? Doesn't really matter actually, because we don't know which one is bigger than the other one. Okay, usually we put like this lah, C2 minus C1, and after that substitute the variable that you know, the values for each variable. Let's say y equal to 5, so put 5, and x equal to 1, so 1 squared plus c, so therefore c equal to 5 minus 3 is equal to 2, therefore y equal to 3x squared plus 2. Alright. Second question, dy over dx equal to 4x minus 1 over x, which satisfy the condition y equal to 6 when x equal to 1. Okay, seems like you akan ada reciprocal function over here. Okay, but hold on, tak semuanya kita kena gunakan k. Alright, so let's take a look. So first thing first, use the separable method. Therefore you have dy equal to 4x minus 1 over x dx, and then integrate both sides. 4x minus 1 over x dx. Integrate 1, you have y plus c1. Integrate 4x, is become 4x squared over 2. Integrate reciprocal, you have ln x, and then put plus c2. Alright. Okay, kenapa tak guna reciprocal? Tak boleh, because ini ada combination between two function. Okay, baru tak sesuai gunakan k. So I lagi prefer gunakan c lah. Okay, now so put your y as a subject because your final answer in term of y. Okay, actually tak perlu pun nak follow final answer ni. Is only a guideline for you guys. Okay, actually you boleh play around with the number, you boleh move the whole thing ni to the left hand side and c at one side, because at the end you nak solve your c, right? So therefore I have 2x squared minus ln x plus c, where c equal to c2 minus c1. After that, substitute the things that we know, which is 6 equal to 2 minus ln 1. Ln 1 is 0. Therefore c equal to 6 minus 2. Ln 1 is 0. Actually 0. Right? So 6 minus 2 is 4. Therefore, the final answer will be y equal to 2x squared minus ln x plus 4. Final answer letak modulus, because ln, the function inside the ln is always positive. So, kena letak modulus lah. Alright, so this is number 2. Number 3, number 4 skip. Okay, move on to question number 5. Solve this differential equation by separating the variables. For each one, use the given condition to write a particular solution. Alright, so let's solve the question number 5. So therefore, if I move this y to the other side, because usually kita letak y at the left hand side, sebab y ni usually is a dependent variable, is it? So 1 dx integration. Therefore, y squared over 2 plus c, x plus c. Okay, so in this case, gunakan x subject. Okay, therefore, you just follow whatever given. Tapi kalau you tak nak follow pun, doesn't really matter. Plus c equal to x. Okay, where c equal to c1 minus c2. Alright, therefore substitute the things that we know, which is 2 squared over 4. 2 squared over... Sorry. I put on the top. Okay. 2 squared over 2 plus c equal to 1. So this is 4 over 2. 4 over 2 is 2. So c equal to 1 minus 2. So c equal to negative 1. Therefore, y squared over 2 minus 1 equal to x. Okay, number 7. So if you're not sure, let's move the dx first to the other side. So dy equal to y over x dx. Then move this y, it's become divide. Ini the divide, is it? Okay. So y dy 1 over x dx. Okay, next. This is quite similar to the example in our delta. Okay, so kita gunakan k lah, lagi mudah, right? Okay, so now ln modulus y equal to ln modulus kx. Okay, kalau tak suka a, boleh letakkan k. I'm sorry. If you a bit confused with the k, maybe you boleh substitute with c. Okay, because it's still a constant, right? Okay, now what's the remaining? Y equal to kx. Am I right? Okay, so substitute the value. Y equal to 4, x equal to 1. So k equal to 4. Therefore, y equal to 4x straight away. Straight away boleh dapat dia punya answer. Okay, question number 9. Okay, question number 9 ni, the answer from delta ni actually not plus 1, actually minus 1. But if anyone managed to get the answer similar like delta, let me know. Because as far what I'm done triple times, the answer is not plus, it should be minus. Okay, it should be minus. Okay, so let's take a look. Alright, so first thing first, we like to change the location of y and x. So therefore I will have 1 over 1 minus y dy, 1 over 1 plus 2x dx. Okay, you have to play around over here. It's going to be like this. Alright, so therefore integration symbol, 1 over 1 minus y dy, 1 over 1 plus 2x dx. Okay, solve for the integration for both sides. Right, so therefore what we have is ln modulus of 1 minus y divide by, you differentiate the function inside the bracket over here, and dapat negative 1 equal to ln modulus 1 plus 2x divided by 2. Kenapa dapat 2? Because you differentiate 1 plus 2x. Differentiate 1, 0. Differentiate 2x, dapat 2. Mana letak k? Okay, so now k, you have to put just beside the 1 plus 2x over there. So k, 1 plus 2x. My god. Ln ln 1 minus y over negative 1 equal to ln k 1 plus 2x over 2. Alright, so over here you have to apply the law of logarithm. When you multiply two function inside the logarithm, actually you boleh separate by put as a addition between two function. Okay, it's going to be like this, which is negative 2. I bring this 2 to the other side, so it's become negative 2. Ini negative 1, so actually negative ln lah. Okay, ln 1 minus y modulus ln k plus ln 1 plus 2x. Okay, so our objective to solve the k, so put this ln k as a subject. So therefore, what do I have is negative ln k equal to ln 1 plus 2x plus 2 ln 1 minus y. Remember our objective to find the k, so I put the k become the subject. Kenapa dapat negative ln? Because I move this ln k to the other side and I bring this negative to the other side. Okay, we're not finished yet. Kat sini, apply the law of logarithm is become ln k power of negative 1. Because when you have a constant in front of the ln, you may bring up become the power. Okay, kat sini pun sama. Ln 1 plus 2x plus, you can say ada 2, so you bring up 1 minus y power 2. And then if you notice, this is a multiply addition, so you ada ln base yang sama, so boleh jadikan dia sebagai single ln by multiplying both, which is 1 plus 2x and 1 minus y squared. Okay, so what we're going to do with this ln and ln, you boleh buat comparison. Okay, so tadi kita ada ln k power of negative 1 equal to ln 1 plus 2x and then 1 minus y squared. So ln cancel out, so it's become k power of negative 1 equal to 1 plus 2x 1 minus y squared. Okay, so therefore kat sini dapat 1 over k 1 plus 2x 1 minus 1 squared. Okay, baru kita substitute the value ya. Okay, so when y equal to 5, x equal to 4. Am I right? Okay, y equal to 5, x equal to 4. So now kita substitute lah. 1 over k, kat sini dapat 1 plus 2 times 4 is 8. 1 minus 5 squared. So 1 over k. Over here 9. 9 times 16 is 144. Therefore k equal to y, k equal to 1 over 144. Alright, so what we're going to do with this k 144, so you boleh substitute over here and then put them as put the y as a subject, because final answer kat sini gunakan y as a subject. Okay, now so k equal to 144, so k inverse, 1 over k is yang inilah. Kat sini lah kot paling mudah, paling mudah. 1 over k is 144, so 144 equal to 1 plus 2x 1 minus y squared. Okay, and then I put this one as a subject. 1 minus y squared equal to 144 over 1 plus 2x. Move this square become square root. 144 over 1 plus 2x is become 1 minus y. So you boleh separate square root 144 and square root of 1 2x. So square root of 144 It's become 12 over square root 1 plus 2x 1 minus y. Okay, and put y as a subject, so definitely y equal to 1 minus 12 over square root 1 plus 2x. So dapat macam ni. So that's why I mention it's impossible to dapat this plus. Or maybe someone who managed to get the answer, please let me know. WhatsApp me. WhatsApp me. Okay. Moving on to the question number 11. Okay. Question number 11. Okay, so and this one also is I didn't manage to get the same answer like delta, okay, but it's almost there. Actually, if we expand the final answer from delta over here, actually we managed to get the same answer lah. Okay, let's try to solve this question number 11. Alright, so first thing first, I bring up the or maybe you boleh rearrange the equation. First is become 5 minus x, and then y dy equal to 5 minus x dx, integrate 5 minus x dx, integrate y is y squared over 2 plus c1, integrate 5 is 5x, integrate x is x squared over 2 plus c2. Okay, now put other than constant at one side, so y squared over 2 minus 5x plus x squared over 2 equal to c. Remember, your c equal to c2 minus c1. Okay, now let's substitute the variable, which is y3 x5. So 3 squared over 2 minus 5 times 5 plus 5 squared over 2 equal to c. So if you calculate over here, your c will be equal to c equal to 8. C equal to 8. C equal to 8. Let's confirm. Okay. So this is 8. 8 over 2 is 4. 4 minus 25 plus 25 over 2. Okay. 4 minus 25 plus 25 over 2. Wait for a while. Oh, this is not. This is 9 actually. This is wrong. 9 over 2. This is 9 over 2. 9 over 2 minus 25 plus 25 over 2. Therefore, c equal to negative 8. Alright, so therefore I have y squared over 2 minus 5x plus x squared over 2 equal to negative 8. Okay. Right. So let's simplify. So if you simplify these two, which is the whole thing, you multiply by 2. So y squared minus 10x plus x squared equal to 8 times 2 is negative 16. So y squared minus 10x plus x squared plus 16 equal to 0. Okay, and this one you will try to press your calculator. Okay, or maybe if you wanted to stop over here, it's also correct, because if you look at the final answer, they give us x minus 5 squared plus y squared equal to 9. If you expand, x squared minus 10x plus 25 plus y squared equal to 9. Okay, so x squared plus y squared minus 10x, 25 minus 9, 25 minus 9 is 16. Okay, kat sini actually x squared plus y squared minus 10x plus 16 equal to 0. So actually similar to the answer that we have. Okay, right, so you may stop over here pun betul, or maybe you boleh rearrange the equation until you have this one pun dapat betul juga. Okay, but for me no need to make more complicated, you boleh stop kat sini je lah. Okay, right, last but not least, okay, number 13. So number 13, again move by using the separable method. You have 1 over y squared dy, exponent of negative x dx, bring up, become negative 2 dy, negative x dx, integrate exponent power of negative x dx. Okay, integrate y power of negative 2 power plus 1 become negative 1 divided by the new power plus c1. Integrate exponent, you will have the exponent again, but divide with, you differentiate negative x, is negative 1, put plus c2. Simplify further, 1 over y plus c, I wanted to put the plus c at the right hand side straight away, equal to negative 1 over exponent of x plus c. Again, your c equal to c2 minus c1. Okay, but since we wanted to solve the c, so put c as a subject, therefore I have c equal to 1 over y minus put c as a subject, so c equal to, meaning you have to bring this one to the other side, 1 over exponent of x minus 1 over y. Substitute the variable with the value given, y equal to 1, x equal to 0, so c equal to 1 over exponent power 0 minus 1 over 1. So c, any number power 0 is 1, so 1 over 1 is 1, 1 over 1 is 1, so c equal to 0. So final answer would be negative 1 over y equal to negative 1 over exponent of x. So since atas sama, right? So therefore final answer will be y equal to power of exponent power of x. That's it. Okay. So I think that's it for our video, and I think this is our last video for this lesson, and I really hope that you guys understand for each chapter that we discuss. I'm really appreciate if you can try to solve the rest of the question that we didn't discuss in the videos, in the whole videos, and I hope that you guys can successfully you can you may understand this chapter very well. Okay, since we still in the MCO, it's very restricted, in order to understand the chapter very well. But if you have any question, just let me know. Okay, so that's it for this video. Thank you.